Hello, welcome to my project. This is the JoJo Momentum. A weaponry? Could it be? Well, we know that JoJos have been part of our childhood for most of our lives. We tend to see it only as a mere pastime or an entertainment, an object fun to play with, oblivious of its true nature. But supposedly in the 16th century, Filipinos used it as a weapon to hunt. They would tie rocks to 20-centimeter ropes and throw it at the animal's legs and paws in order to slow them down or knock them out. What if I told you that these toys could become a weaponry? Well, this thought came to me as I was watching an anime called Hunter x Hunter, where one of the characters named Killua Zoldyck uses JoJos as his weapon. You know, as plain as a JoJo might actually seem, it has a periodic function, or a motion that is repeated through equal interval of times. If this were to be swinged, there would be a build-up on momentum, and the impulse of the blunt force would be immense in its landing. This in mind, today we will be looking at the possibility of landing a blunt attack with JoJos through a set of experiments. Let's find out. As I was developing this experiment and considering the JoJo momentum, a few questions came to mind. First of all is, how does the variable of length affect the velocity and speed of the JoJo? Obviously, if we look at a JoJo, we know that it has a string and a circular object attached to it. So, I was thinking, how does the length of this thread, this rope, this string, affect its swinging rate? Also, which material could be best for a JoJo to be sort of military-like? Or which material could be best to replace the rope with? I was reading in some studies that the rope could be weak, but actually the string worked just fine for me. Now, for a JoJo, plastic could be an option. Those were the ones I used because I couldn't find aluminum metal ones. But preferably, if we're going to be using them as a weapon, right, or make like a military JoJo, then an aluminum JoJo would be best, since it would have a harder force when it hits. Another question that came to mind was, how does the body position affect the propellant or the propellant of the JoJo, the distance it covers and the tension of the string? Does breaking the cycle in order to land the hit affect the momentum? And how do collisions differ with objects of angular momentum? So in order to answer these questions, I had to develop a series of experiments. With them, I had, first of all, just a JoJo horizontal swing. I just basically swinged the JoJo horizontally above my head, just to sort of understand how periodic functions work, first of all. JoJos that have shorter ropes work better, since you have more control and aim over them than the ones with longer threads. So I had to kind of like tie it up a few times around my finger in order to have it just the right amount or just the right length for it to be under my control. That depends on the person per se. I was also thinking which number of cycles I had was best to release my attack. And after doing it, I saw that just after completing 6 cycles, meaning that I did the 6, and if it were like I was going to start the 7th, instead of doing a whole complete cycle for the 7th, I would land the attack there. So I would start it, but then land the attack, and I saw that that actually built up a good speed and momentum. To measure this, obviously, I used a watermelon as the person that I would be hitting, because no violence here. Obviously, with the experiments and the questions, I developed hypotheses before I completed them. With my prior knowledge of pendulums, which also depend on the length, their swing and rate, and with my prior knowledge to periodic functions. So I said, if I were to swing the yo-yo with a shorter thread, then my distance would be limited, meaning I would have to be closer to the enemy, but my control over it would be firmer. Now, I said that if I were to swing my yo-yo with a longer thread, that I would cover a longer distance or a larger distance, but my aim might be off, which were some things that I saw as I was doing it. I saw that when I was closer, I had better aim. Right now, you might be confused by what I mean with blunt force trauma. This is a certain trauma that derives from injuries that result from an impact with a dull firm surface or object. Some examples of this trauma could be transportation fatalities, jumps from heights, and, as I have said earlier and I have mentioned earlier, being struck by a firm object, which in our case would be the yo-yo. As I was researching, I found out that in order for the force to be blunt, the object must go through a combination of forces, meaning that it should accelerate and decelerate, and that there should be an increase and decrease in speed of the moving object. Fortunately, if we compare this to the yo-yo momentum, since it is a periodic function, it works just fine. A periodic function's graph would have a wave pattern, since the mass of the yo-yo is undergoing changes in its speed in a suicidal fashion, meaning there are times when it accelerates and it decelerates. When I mean decelerates, it's not that it slows down, but rather there is an energy loss. Over here you can see me swinging the yo-yo a few times and landing 3 hits overall. As you can see, the watermelon actually had an opening, so its shell was affected, and we know that watermelon's shells are pretty hard, so this was successful. In fact, yo-yos can be used as a weapon. Now, I wouldn't recommend it since you would be very close to the enemy.